Welcome to CML InfoTech. Today we are going to talk about switching from CCNA. So switching means sending data within the network, also known as LAN, local area network, or networking. When the networking performed by switch, we considered as switching. Before, there was a product called bridge. This is the symbol of bridge. The bridge is also used to connect any edge devices like a system, camera, etc. So when you connect edge device to the bridge, still we call it as a LAN or networking. When those are performed with the help of bridge, we call it as a bridging. There was a paper from Cisco, bridging, even from CCNA as well as CCNP, also in CCIE. It was a decade before. Now, they replaced with switch. So you can see a symbol like that. We call it as a switch. When you connect your edge device, it could be anything like access control system, BMS, access point, system, printer, scanner, phone, or any edge devices. When you connect those edge devices into a switch, when they do start communicating each other, we call it as a switching. When we say switching, it's generally a function from layer 2. So what does it mean by layer 2? It's a data link layer from OSI. Any device who take decision based on MAC address, then we call it as those devices are from layer 2 because the layer 2 address is called MAC address. So if any device who takes decision based on MAC is called as a layer 2 device. Example, switch. So when we say switching, which is the functionality from the switch, we call it as a layer 2 function. So in shortly, layer 2 address, MAC. Layer 2 device, switch. Layer 2 function, switching, which means connecting devices in the switch for them to communicate each other. So we are more talking about switching, or we can say we are talking about the layer 2 functionality. So we have a switch from layer 2 as well as layer 3. When we say layer 2 switch, called switching, and when we say layer 3 switch, call it as MLS, multi-layer switch, which can perform switching plus routing. We'll discuss routing later today or later upcoming session more about routing. The way we also have the switch which belongs to layer 4. The switch can perform any functionality from layer 4, we consider as a layer 4 switch. However, in any upper layer switch, which always starts from layer 2, that is the default function. If you have a switch which can do layer 3 functionality, it will not do automatically. You need to perform by enabling those layer functions. So we talk about layer 2 switching. What is layer 2 switching? It's very simple concept. When you have a switch connecting many devices to that, they can send and receive the traffic between them, called switching. So of course, we're going to attach the system into a port of the switch, like for example, F01, F02, F03, the switch must have ports, maybe 8-port switch or 24-port switch or 48-port switch. So the edge devices, we must need to connect it to a respective port of that switch. Then they will communicate to each other. How a system or any edge device, when we connect it to that switch, how they are communicating each other. There are some points that we need to understand. The first, when you say switch, which is a layer 2, as we said before on the previous session, the switch will have a MAC address in order to address that the switch working from the layer 2 perspective. And you have a port on the switch. Like, for example, if you have 8-port switch, the port starts from 1 until 8. And you can connect any edge devices into that port. And the edge device, example, if this is the system, you can see this is NIC, Network Interface Card of that computer. The system, which has an NIC, will have the MAC address. And the MAC address is the combination of A to F0 to 9. It's a hexadecimal value. So example, if I'm going to mention that 1111A, 111B as an example, as the same sample copy of the MAC. Also, your port of the switch also have a MAC. Same thing, the MAC address is a 48-bit or 12 hexadigit. So the switch will learn the MAC of that port as well as the system which attached to that specific port. So the system, the switch will have a 2 MAC on each port in shortly. Which are the 2 MAC? Let's say the switch has a table called MAC table. Initially, the MAC table is empty. It contains nothing. When it starts to communicate, the MAC table will be filled with the MAC address. Let's say, for example, the port number 1 will have the static MAC. Also, the MAC table will have the MAC of the connected device, which we call it as a dynamic MAC. There is a process how a system will communicate it to another system via switch, or what is the major functionality of the switch in order to help the edge devices to communicate each other. We will learn about the process, by the way. So, in the short any device which you connected to a switch will have the MAC address, which is considered as a dynamic MAC. So, will help you to address the process, how it works. Okay. You can understand that it's more important. We will talk about 2 systems. You have a PC1 and you have a PC2. The PC will have NIC, Network Interface Card, NIC. And NIC will have a MAC address, which is 12 hexadigits. Example, let's say 1111, 4 hexa, 4 hexa, 4 hexa. Why I mention 8? Because the MAC address is the combination of numbers and A to F. This MAC 111, 111, 111B. This for us, it easily identifies the MAC address. Again, the system must have IP address. IP address is given by us. The MAC address is manufactured from the manufacturer, which will be built in with the MAC with NIC card. That's IP address. Example, I'm going to give 10.1.1.1. 10 is a class A, therefore you need to mention /8. 8-bit is on. When the 8-bit is on, your MAC address, so your subnet mask must be 255.0.0.0, which means the 8-bit is on. The value of the 8-bit is 255. When you mention the second system IP, which must be the same network of PC1, let's say 10, 1, 1, 1, 2. Here, this 10 and this 10 must be matched. The reason why, first of all, it's a class A. Then it's the default prefix length. The 8 we call that prefix length. That is a technical name, prefix length. This 8 can be 9, can be 10, until it can be 31 or 32. Even if it's a class A, which is 10, still the 8 can be changed to until 31. So when those values we are considered as classless or subnetting. We'll learn it later, inshallah. But now, all the IP which we are going to mention here is a class full. Class full means without subnetting, and if you mention any class full IP from class A, which is starting from 1 to 126, then it must be /8. When I say /8, the first octet must be matched from all the systems, like here from PC1, also PC2, and the subnet mask is 255.0.0.0. Now I need we need a communication between PC1 and PC2. So what we're gonna do, we have a switch here. We'll connect it to the port, to the NIC, and here to the NIC. Let's say, for example, this is F01, F02. What is the meaning of F? F means fast Ethernet. When I say fast Ethernet, the speed of the interface is 100 Mbps. So it will be start like E, F, G. Ethernet, fast Ethernet, gigabit Ethernet. Ethernet 10 MB. Fast Ethernet 100 MB. Giga Ethernet 1000 MB. Then we have a 10 gig, we have 20 gig, we have 25 gig, we have 40 gig, we have 100 gig and above. Depends upon the model that we have, depends upon the port capability. So let's say we have 2 ports which we connect to each other. Now we are talking about the process to understand how the PCs are communicating. Not only PCs, instead of PC, it could be any edge devices, how they are communicating. The switch has a table called MAC table. Initially, the MAC table is empty. When a PC starts communicating to PC2, just remember about the OSI layer concept. Let's say the PC1 is generating a communication towards to the PC2. So what will happen? It must have data, then source port, destination port, depends upon the application that we're going to use. Then source IP, destination IP. Then source MAC, destination MAC. This is the minimum communication that is required to transfer a data from PC1 to PC2. So the PC1 try to learn about this content. Let's say source port and destination port depends upon the application that you're going to use. The source IP, which means the sender IP, who is sending. So here the sender is PC1. Sender means from. So let's say the sender IP is 10.1.1.1. Now it needs to know about the destination IP. The destination IP, which is 10.1.1.2. This is given by the user or the admin. Then it needs to mention the source MAC address, which is sorry, 111.111.111.111.8. Now it needs to mention the destination MAC address. Initially, the system will not know about any other. And the sender mattum da theriyum, vera yarume theriyadu. So what will happen? The sender will request to everyone to know the specific destination IP. Let's say in our class we have 10 people. I do not know the specific person. What I'm gonna do is I'll just forward my traffic. Hey, let me know this guy is available or not, or what's his name, which means broadcasting to inform to everyone to know the specific person in the class or in any specific place. For example, in order to know the specific IP 10.1.1.2, where they are located, the PC1 does not know the destination IP or the destination MAC address. So what it will do, it will send the broadcast. The broadcast here means FFFF. So how we will say the FFFF is a broadcast? So here, if you look into the MAC address, the MAC address is 48-bit binary, which means binary means 0 or 1. So let's say 4 bits will convert it into 1 hexa. The 4 bits means it would be 2 raised to 0, 1, 2, and 3. So it completely starts with a 0, which means 0. So 2 raised to 0 means 1. 2 raised to 1 means 2. This is 4, and 2 raised to 3 means 8. When I say completely 0, which means 0. And it will be incremented 1, 2, 3 like this, and it will go up completely 1, which means 8 plus 4 plus 2 plus 1, which is equivalent to 15. When I say 15, this is the decimal value. According to hexa, it starts from 0 to 9, then A to F. A to F means A, B, C, D, E, F. So after 9, A means 10, B 11, C 12, D 13, E 14, and F 15. So F 15 means F. So this is for 4 bits. The 4 bits, they also called as 1 nibble. Okay. So the 4 bits, if the 4 bits of combination is equivalent to 1 hexadecimal. So if I'm mentioning 4 bits into 12 times, like this is 4 bits, which is the combination of 0 to F, 1 hexa. Again, I'm going to mention another 4 bits, which is again start from 0. If I'm writing 4 zeros in binary, it would be a single 0 in hexa. Then it will come up to completely 1, which means F. So this is the second nibble or second 4 bit, which is totally 8. The way, if I'm mentioning 12 times, this is just the 2 times. If I'm mentioning 12 times, so 4, it will become 48. Which means, if I'm writing something, let's say, 1111, 1111, 1118. This is one of the MAC. What does it mean? This one is 1 hexa. This one means 1 hexa. This one means 0001. This one means again 0001. This one means 0001. This one means 0001. So here we have total 8 plus 8, 16 16 digits. So 16 plus 16, 32, 32 plus 16, 48. So here if I'm expanding the hexa, you're going to get that 0001, and this is 0001, this is 0001. So what about A? So the A means 0 to 9, then A. So the A means 10. In order to get the 10, 8 plus 0 plus 2 plus 0. 8 plus 2, 10. So which means 1, 0, 1, 0. So let's say 1, 0, 1, 0. So this, whenever you are expanding any hexa or decimal towards to your binary, make them 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3 value combination. Then write the exact outcome of those values. And wherever it is 1, you need to add. Wherever it is 0, it remains 0. So coming back to all this point that we are explaining about the MAC concept, MAC construct. So the total 12 hexa will be a combination of 48 bits binary. So we're coming back to the point. So the MAC address will not be completely 0, and it will not be completely 1. It must be anything in between. So when I say completely yes, completely 1, which means your 4 bits is 1. When I say 4 bits is 1, which is 8 plus 4 plus 2 plus 1. The complete 4 digits are 1, which is equivalent to 15 or F. So if I'm writing 12 hexa, F means the complete bit is on, which is the another name of broadcasting. So we're coming back to the point. Here I'm writing completely F, which is the broadcast. And the PC1 is sending to the port number F01. Let's say you both are systems connected to me as I am a switch. So Prem wants to talk to Azim. So let's say this is Prem and this is Azim. Prem wants to talk to Azim. So Prem is requesting me to have a conversation with Azim, but the Prem does not know who is Azim. So he's asking me, kindly connect to me to Azim. This is the conversation. So you're coming to me. So this MAC table is my brain. So I need to think what's your query, whom you are asking, so what is the name, all information that I need to capture. So when the switch receives a frame, because of layer 2, we call it as a frame. When the frame received by the switch port, that's the first task of the switch port. It will be addressed that where it is coming from. So it mentioned that the query is coming from port number F01. So it will mention it's coming from port number F01. And what is the MAC of that source? Source means the sender. It says that it's coming from F01 with a MAC address of 111111111A. So it will be feed those info into their table. So if you, the Prem asking me to communicate with Azim, my first question that, what's your name? Who are you? Or where you're from? Whom you wanted to talk? So the first I'm collecting the source info. I came to know that it's a Prem or the source MAC address. So I mentioned the source info. My second task, once I learn the source info, my second task that whom should I send, or whom you want to talk? Why did you came? What's the destination that you want to talk? And the destination information, I'm going to take it from the incoming frame. When I look into the destination MAC address, because we are talking from layer 2. When I say layer 2, the conversation, the communication, the discussion, everything based on MAC, not based on IP, because IP is a layer 3. We are still layer 2. So I'm going to check the destination MAC table. I came to know that the destination MAC table is FFFFF. So I don't have any specific destination to be forwarded. Instead, because of FFFF, I will forward it to everyone. Whoever connected to that switch, I will forward it to everyone, including F02. And everyone who all are received will look into the destination MAC address. Let's say I connected to one system here, which is the destination IP 10.10.1113. Maybe another person. So the PC1 info from F01, once received by the switch, because of destination is FFFF, the switch will forward it to everyone, excluding the receiver. So it goes to port number F03 and F02, both are received, both are checked the destination IP. And the 10.1.1.3 will say that this is not for me because my IP is different than the received IP. So the F0/03 will be discarded. But the PC2 will address that the received info is to me. So I need to react. So what is the react? So this is asking about the destination MAC address because the FFF. So the sender will send to the respective, the sender will send to the switch, and the switch will broadcast to everyone to get the exact destination with the help of ARP protocol. So what is the role of the ARP? To find the MAC address based on IP, address resolution protocol. Let's say the PC2, which is Azim, receives the frame and it came to know that ARP request. The ARP means it's requesting to know about the MAC of the sender or of the receiver. Now, the PC2 need to inform back to PC1 that this is my MAC. So the PC2 will regenerate a new frame. Let's say, what is the new frame from PC2? So the PC2, so here, PC2 111B will send to PC1. It's a return traffic. So data, or before the data, it's just the communication. We'll talk about the source IP, destination IP. Now the source IP is 10.1.1.2 because now the source is PC2. The destination IP is 10.1.1. Source MAC, now the sender is PC2, sending back 111B. And the receiver or the destination MAC is 111A. The destination MAC will receive from the incoming frame. If you look into the incoming frame, we can see the PC2 receive the frame contains the MAC. This is the source MAC when PC1 sent to PC2. Now it's the return traffic from PC2 to PC1. So the 111 is the destination MAC. Now it will fill that BB. So this is the return traffic, which will be sending by RARP, reverse address resolution protocol from PC2 to PC1. Again, the same procedure. It will come to F02. So the first task of F02 to address is coming from which port? It says that it's coming from F02. And the MAC of the PC2, which is the source MAC, B. Now, once the source info is learned by the switch will look into the destination where it needs to send. The return traffic has the destination MAC 111A. If it has, then the switch will be looking to the MAC table. If the MAC table still present that info, will forward to the respective port. If you remember, when the ARP conversation happened, the MAC table is already mentioned about the F0/1 with the respective MAC. When it is coming back from the switch, it mentioned that it's coming from F02 with the MAC address 11B. Then the switch will be looking to the destination info, which is 111A. It has already in the MAC table, will forward it to the respective port. Then, once the system receives this info, the system will be keep those info within that system, which is called ARP table. So let's say, for example, if I am going to look this command called ARP minus A, you can ARP minus A. You can see many IP address. 192.168.1.1 is my gateway. This is my gateway and the MAC address. And you can see dynamic. The MAC address we can see via static and the via dynamic. Dynamic is the one which is the other side of the device MAC. So what does it mean by ARP minus A? இப்போ வந்து பிரேம்குட் அசீஸ் தெரியாது, அசீம்னு தெரியாது. இப்போ பிரேம் வந்து எங்கிட்ட பேசுவார், எனக்கு அசீம்னு தெரியணும். நான் ஃபர்ஸ்ட் வந்து கேட்போம், what's your name? So you want to say that my name is Prem. So I'll keep those info in my table, which is the switch table. Then I'm going to ask you where you want to send. So based on your destination info, I will forward it to the respective team. If I do not know this guy, I will openly ask, who is this guy? Or open your hand, or raise your hand. The way I'll address those guys, and he will reply back to me. I'm sitting here. I need to inform back to you that where is he. When I inform back to you, you need to keep those entry into your table. The table is called ARP minus A or ARP table. The same table available in the switch as well. So when we look into the switch ARP table, we will come to know the IP along with the MAC address. So the function of the ARP, if you know the IP, it will address the MAC. If you know the MAC, it will address the IP. So this is the basic functionality of any device who connected to the switch. This is just a system. If you have any other devices, like any edge devices, the functionality is quite similar for any conversation. So I'll brief the conversation. A system need a destination MAC to have a successful communication, and the system will send to the switch. The switch port, once the switch received from the switch port, the first task switch will be learned from the source info. Then it will ask about the destination. If it does not know the destination, it will broadcast to everyone. Once the respective destination is like respond on that, the destination will reply back to the source with RARP. Again, it's coming back to the switch. Switch will address the source info, then we'll look into the destination based on the received frame, then compare with the MAC table, we'll forward it to the destination. Once the sender and receiver came to know each other, then they will send a unicast frame. Unicast frame means it just straight forward to the respective destination. If it does not know, then it will broadcast, of course. This is the common way of a conversation between any two devices or any devices which connected to a respective central device, like a switch. Any doubts? We will look into the upcoming session with a practical oriented. Thank you for joining with us now. The summary of the session today, we were discussed about how the two devices communicating through a switch. If the switch knows about the device knows about the destination or not. So we'll continue with the practical session on the upcoming slides. Thank you. Have a great day.